Greetings. Today we're going to present a smart inventory management system, or we call it as SIMS, developed by Amirul Hafiz bin Anwar, Isaac Ran Korean, and Abdalla Hashim Ahmed Abdalla. So we move to the problem statement. Whereas the many retail businesses struggles with inventory management due to inefficiency in tracking stock levels. The traditional manual methods like spreadsheet or handwriting logs lead to frequent errors, stock outs, and overstockings, impacting profits and customer satisfactions. Additionally, the lack of real-time data hinders effectiveness in decision making also. Then we going to the target audience and functional goals, whereas the summary is the SIM is designed for a small to medium-sized retail business. It automates inventory tracking via barcodes or RFID and also provide real-time update and send low stock alerts. It's also streamline communication between store managers, warehouse staff, and suppliers. Okay, we move to the key functional requirement. The first one is the user authentications, where only authorized user can access the system. The second is the real-time tracking, where the instant inventory update via barcode or RFID. The third one is the low stock alerts, whereas automate alerts when stock is low. The fourth one is the purchase order, where it automatically generate orders based on the stock labels. And last but not least, 5. Style stress analytic. It does come with a dashboard to show real-time sales data for better decisions. Next, we do have the non-functional requirement, whereas the performance support 50 plus users simultaneously without lag. And the second is we do have the security, where it's use AES 256 encryption and role-based access control. The third one, we do have the reliability, aims for 99% uptime for business continuity. And last but not least, for the usability, it is intuitive user UI or user interface for different user roles. Okay, that is from me. I'm passing to my friends Amirul Hafiz.
Alright, thank you, Isaac. Move to analysis model use case diagram. We have 5 actors, which is store manager, warehouse staff, supplier, business owner, and IT department. And 6 use case, which is mobile access, inventory tracking, low stock alert, purchase order generation, sales trend analysis, and user management. For the mobile access, inventory tracking, and low stock alert, they connected with store manager and warehouse so they can access the apps to do the inventory tracking and alert with the stock inside inventory. For the purchase order generation, is connected with the store manager and supplier, so store manager can directly purchase the product from the supplier. And then, for the business owner and the store manager, is connected with the sales trend analysis, so they can check the trend of the sales of their product. Lastly, store manager and IT department are connected to the user management, so they can have a new user and creating or approving such a job as a storekeeper and other job. Alright, move to analysis model activity diagram. This diagram shows the mobile access process for warehouse staff and store manager. Warehouse staff log in to check and update inventory details, while store manager use the system to view sales and analyze trends. This ensures that both roles can efficiently perform tasks using mobile access anytime and everywhere. Next, move to inventory tracking. In this workflow, both the store manager and warehouse staff play key roles in tracking inventory. While the warehouse staff record and update stocks, the store manager verify and update reports accordingly. This keeps inventory data synchronized and ensure operational transparency. Move to low stock alert. This diagram shows the low stock alert process involving both warehouse staff and store manager. The warehouse staff identify low inventory, update the system, and send a report. The manager then verify the report, handle restocking, and update inventory record. If the report need revision, is sent back for the correction. These cycles help prevent stock shortage and ensure efficiency inventory management. Move to purchase order generation. This workflow outlines how a purchase order is created and processed between the store manager and the supplier. The store manager identifies items that need replacement and send a purchase order. The supplier then review the order, confirm or reject it, and provide feedback. This process ensures that the inventory is restocked accurately and stores stay updates on the status. Move to sales trend analysis. This diagram shows how the store manager and business owner collaborate on the sales performance. The store manager digs into details trend analysis while business owner evaluate high value summaries against business goals. Feedback is sent to the manager for the further action, ensuring strategic alignment and data-driven decision. Lastly, user management. This diagram shows connection, store manager and IT department that how user requests are handled. Store manager submit a request, IT department review, approve or reject, then send back an update. It ensures only authorized user can access or change roles. Move to high-level architecture and architecture overview. Our smart inventory management system use layer architecture, which is three-layer architecture. First, the presentation layer is the front end where user like a store manager and warehouse staff interact with the system through web or mobile apps. Next, the business logic layer handles user input, apply business rules, and manage operation like inventory update and purchase order. Finally, the data storage layer keep all crucial data such as inventory, user roles, and logs. It supports data access for the logic layer. By separating this layer, the system becomes easier to maintain, scale, and upgradable. Move to our friend Hashim for presenting.
Moving on to the design models. First, the model we have is the class diagram. This is the class diagram. It outlines the main entities and their relationships with the system. First, we have the user class. It's the base class for all users. The attributes of this class is that user ID and username and role. Also, in the user class, we have the methods. We have two main methods, the login and the logout. And also, we have the subclasses. We have the store manager and warehouse staff and IT managers. Also, we have the inventory class. We have in the inventory class attributes and methods. The attributes we have is the item ID and quantity and the threshold. Also, in the methods, we have update stock and is low stock to check if the stock is low or not. And lastly, we have the sales trend analyzer. This class analyzes sales data to generate future sales forecast. Moving on to the next model, which is the component diagram. This diagram will also elaborate our system. In this diagram, we will first see the presentation layer. In the presentation layer, we will have the components of it, which include the mobile app interface and also the logic / the registration screens and also the inventory viewer and mobile app interface. And the functionality of the presentation layer is to enable user interaction via mobile or web and communicates with business logic layer for inventory updates and report generation. Second layer we have, as it's seen here, is the business logic layer. In the business logic layer, we have first the components, which consist of the managed inventory, where the inventory get updated and threshold checks. Also, the sales report generation, where we create sales report, and also we have the purchase order generator, which also automates the purchase order based on low stock. And additionally, we have the user management and we have the alert system. The functionality of this layer is to process data from the presentation layer and applies business rules and interact with the storage layer, which act basically as bridge between the presentation layer and the storage layer. And lastly, we have the storage layer. The storage layer components. First, we have the inventory database where we get to store the item and data and thresholds. And also we get to restore the sales and the report in the sales and report database. And additionally, we have the purchase order database where we get to store purchases and orders and also their status. And lastly, in the storage layer, we have the user database where we get to store the credentials and roles. And eventually, the functionality of this layer is to store and retrieve system data for the business logic layer usability.